The primary thing that I want to tackle today is I want my Centurion back. I want to be able to walk up here, flip that power switch, and start using my Centurion again. If you're not familiar with the Centurion, I've got a huge series on it. This is like one of the first really big, serious projects that I undertook, and I love this machine. It is beautiful and quirky and weird, and almost everything you see here works, except for the Phoenix drive over there, which if we've got time, we're gonna try and get that up and going in this episode as well. But everything kind of slowed down because we were running into power delivery problems. The wall outlets in here are on a 20 amp breaker, and with two Hawk drives, a Phoenix, a Finch, a data terminal, an EDS-PC, the printer, and the Centurion CPU itself, we were like gonna break 20 amps and it was gonna start popping breakers. So we got to figure out how to get better distributed power to this. That'll create kind of a nice balanced load, I think, and then we can have my Centurion up and going. But if we're running 30 amps clean over to this, we also need to continue running it that way. And that's because over here we have the JL Jamp 10S OJ microprobe. This is not a scanning electron microscope, although it can do electron imaging like a scanning electron microscope. I am incredibly excited about this project, but it needs power, and it needs weird power. Thankfully, we've got the manual here. And if we look through this on one of the pages here talking about what it takes to install this thing, it says the power supply is single phase 100 volt 30 amp and 200 volt 20 amp at 50 or 60 hertz. So the 30 amps that we're running to the Centurion, we're gonna continue to run that clean over to here, so that way I have 120 30 amps ready for this guy. We're also gonna run 240 volts along pretty much the same path that we're running that 30 amp dedicated circuit, and we're gonna get that all the way over into this corner as well. We're not gonna wire up any sockets on this thing right now, but we're just gonna get the wires there for the future. But the big problem here is that it's 100 volt and 200 volt. And that's because the JL systems are Japanese imports, and the electric system in Japan is 100 volt and 200 volt. So I cannot come up with a good way to take 240 down to 200 without breaking the bank and just buying a huge transformer for thousands of dollars. So if you have a good idea about that, sound off in the comments below. Now I keep saying we, because if I did it as I alone, I would do it like the redneck that I am, and I would end up lighting the entire room on fire. Now I keep saying we, because if I did it as I alone, I would end up doing it like the redneck that I am, and I would end up lighting the entire room on fire. I did it twice in a row. Now I keep saying we because if I did it as I alone, I would end up doing it like the redneck that I am, and I would end up setting the entire room on fire. So my buddy Rick has flown in, and he's gonna help me do it right. Now Rick, say hi to everybody first of all.
Hello.
This is not your first time to play with the Centurion, right? Because
No.
we did some pretty interesting stuff with it before.
Yeah, so I've logged in remotely. Future video.
Yeah, we're working on that. Yeah.
And at one point there was a lot of interest in using a floppy emulator with the Centurion, and it would end up being a lot more difficult. So I did a bunch of work actually getting flash floppy working with a Gotek to be able to boot and run on the Centurion.
Yeah, so if you open up HXC and you're looking through like different floppy images, there's now an option for Centurion on it.
Yep.
That's your fault.
That is my fault.
So I've got the right person in the room. He's also incredibly smart when it comes to wiring things up. So we're just gonna get to work. We're gonna wire it up, and then we're gonna fire up the Centurion and let Rick get hands-on with the thing in person, because I think that's gonna be awesome. While we're moving at light speed here, it's worth mentioning that the electrical code is wildly different from country to country, and also that the code isn't necessarily equivalent to best practice. Just know that we did it right, and the massive hole in my bank account to get all the right parts is plenty proof of that. Now to power the heavy hitters of the Centurion, notably the CPU and all of the drives, we've got this massive twist lock 30 amp rated socket down here. Coming out of that, we go into this PDU up here, which is actually salvaged out of the DEC PDP-11 rack over there. But it makes a great PDU because I can plug all the stuff into here on the bottom, and then I can control the switching of it right here with this little switch on the top. If I switch that over to B, it actually turns everything on. But if it's in O, it's off, or you can, I think, switch to A and control it via these Molex connectors up here. So that way you can do DEC sequencing or whatnot. But it's got a massive contactor in there. This is specifically meant for switching on hard drives. I think this is gonna work perfectly for what we need. Which means it's time to start flipping switches and see if my Centurion will come back to life here. First of all, let's make sure that the power switch is off. And then we'll start by turning on this data terminal, and we'll also bring up the EDS PC because we're going to use that as a second data terminal as well. And because these are plugged directly into the wall, not into that PDU, we can actually bring them up with the PDU fully off right now. The primary ads terminal, which is our console terminal, just came up, and now it's waiting for the Centurion to come up, which eventually we'll get a D equals prompt. For the EDS PC, we got a little more extra work that we got to do. And even though it says EDS on the front and has a little Centurion emblem up here, this is just a PC. The only real program that I have on here is PC Plus. So if we do a CD PC Plus to get into that directory, and then we just run PC Plus straight from there, this is going to load up Procom Plus, which is a terminal emulator program. So I can use the serial terminal on the back of this to plug into the Centurion, and then we can have this act as CRT1 for the Centurion mini computer. Both terminals are up. It's time to flip the switch on that PDU. Now, when I do that, both of the Hawk drives should turn on, but not start spinning up. We should just hear the cooling fans kick off. So I'll reach right back here, flip the switch, and yeah, there we go. Both the cooling fans for the Hawks have kicked on. Now we can start flipping switches and hopefully booting into the Centurion. Now, in between camera takes here, we did actually spin these up with the heads unplugged so that we could purge them for a while, because it's been a while since they've run. It's always good practice to do that. I don't want to show that because it's like super hyper boring to watch. So these should be clean and clear and ready to go. So we're just going to go ahead and spin them up. I'll hit the start and stop button on this one. It's going to start spinning up. Yep, there we go. It's mostly up to speed. It has about a 50-second boot up cycle, so I'll hit this one over here so it can spin up. And then once both of these go ready, we're good to go. And there we go, the ready light came on. That's always a terrifying wait, but I don't hear anything that sounds untoward, so I think we're ready to go. So we'll flip the main power switch key here. That looks like it came up. It did come up in halt, so we'll just hit load opsys. That should get us a D equals prompt. That should have cleared the screen up there. There it goes. All right, now we just type H1. I heard both Hawk drives do RTZs. It's gonna start booting into the operating system. This is hyper promising. This is really exciting. It's been a while since I've had this guy going. Oh no, oh no, what happened? It failed. This is crazy. I have no idea what this means. It's just puking this error over and over and over again. CD01, level 00, map 00, IAD 13F1, EAD 0, all zeros. Oh, that's fun. All right, let's try a load opsys again, and we'll try an H1 again. Maybe we had some kind of conflict or something. This time it worked. Okay, I have no idea what's going on here. CRT0 ready. All right, we'll do a .sta here. It detects all 6 drives. I have no idea what that was. Okay. Oh man, got me sweating bullets over here. But either way, it looks like we're fully up into the operating system. I did a .sta, which got me in there. So Rick, if you can do a control C on that guy.
Yep, CRT1 ready.
There we go. Do a .sta for me. There we go. We are multi-user using the Centurion. That's
nice.
That's pretty exciting. Now we got to do fun stuff. I'll do a .load basic. That should load the basic monitor. So if you do a .sta over there, that's going to reload your status screen, and yeah, there we go. Basic monitor loaded. So you can start writing your basic program. While you do that, I'm going to turn the printer on over here. It's coming up. I'll kick it onto ready. The light should come on it here shortly. Yep. So he's writing a basic program. I want to test out the printer over here, so I'm going to do an s.lst of basic ed, because that's currently in use. And we're going to do that onto PRT0, which should be my printer over here. So if I hit that, that's in library Usagi. It should start printing over here. It is. So Real deal multi-user stuff going on. Both of us are accessing that file at the same time. That's hyper cool. Now, if you type run on there we go, it compiled. There it is again. Excellent. Real deal multitasking going on, but the humans are what's letting us down here. All right, so the Centurion is fully working, aside from that weird error that we had at the beginning, which I couldn't replicate. So, I don't know, we'll just blame it on solar flares.
Sure.
Everything is fully working. Even the printer's printing nice, and it was in a good spot on the ribbon, so we were getting nice dark prints out of it, except the Phoenix is not fully working. Now, in the previous episode, which was probably 6 months ago at this point, we did actually get the Phoenix spun up. I had the heads loaded on it, and we were able to read the removable platter. We even found some source code on there that we pulled off, but we couldn't get it to read the fixed platter. Now, the heads were still flying totally fine, so we didn't have a head crash. So nothing mechanical has gone wrong, but something electrical has gone funny. Whenever I hit the start button, the ready and the fault light flash and kind of flicker together. But also I think we had some grounding problems going on because I did not run a grounding strap between the Phoenix itself and the card cage down there. So that could have been contributing to it. So I think today what we got to do is we got to get that grounding strap run, and then we need to bring the Phoenix back up. But, well, this is where you come in, because the filter that was on this was the original filter from like the mid 90s. And you are actually in an interesting situation where you have found a Centurion up north.
Yeah, so the Interim Computer Museum in Seattle ended up with some of the machines from the Living Computer Museum that closed a few years ago. And part of that was an unrestored Centurion CPU6. But that system only has a Phoenix. It's just the CPU6 card cage and a bunch of MUX boards and RAM and a CMD card with the Phoenix. So the only way we can boot that system is to actually get the Phoenix up and running. But unlike yours, the original filter, the front end of it is just black with dirt. So like, it would be unsafe to really try to use that.
Crash immediately.
Right. So we got on this problem of, David and I started talking around where would you actually get replacement air filters for these that haven't been manufactured for 20, 30 years. But it turned out that when I pulled the air filter out of the ICM's Phoenix, it actually was a replacement part made by the HEPA Corporation in California. On a whim, I just emailed their info and said, hey, do you actually make this? Because it turns out on their website, on their page for custom air filters, there's a picture of the Phoenix air filter on their website.
That's awesome.
And it took them a very long time to get back to me initially. And they said they were pretty confident that they couldn't make that exact air filter anymore. They had lost the plastic molds many years ago. But that if I could turn it into a rectangular filter, that was something that they could manufacture for me at the same specs, as long as I could come up with whatever adapters I need to actually make the fit into the rest of the housing. So I've been working on building 3D printed caps that just attach onto the ends, and that fits the air filter perfectly. So I've brought literally the first prototype to David so that we can put it together and get it test fitted. I've done some test fits at the one in ICM, but this is the first one that probably should be completely fit. And took some time to actually get the right gasket material and everything and cut it out. But this is a brand new Phoenix filter made by the HEPA Corporation.
Like, this is insane. The date on it is 2025. Yeah. How cool is that? So all we got to do is we got to take these and slaz them on there with some probably high quality silicon or something like that. Yep. And then that'll be a box that we can put into that Phoenix, which is good. The Hawk is a tank. It's like a battleship of a hard drive. You could almost run those without filters and they won't crash because the Hawks are just so good. But the Phoenix is incredibly finicky. I was always taking a risk running the original filter, but now that you've done this legwork for a brand new filter, that opens up incredible possibilities, which means also that ultimately for the Hawk, I'm going to need new filters someday. So if this works well, we can adapt that to the Hawks.
Yeah, actually, since I figured this out, as long as we can, for pretty much any air filter in any of these vintage machines, as long as we can figure out a rectangular section, HEPA's happy to make them at, I'd say, reasonable cost. It's not inexpensive. But the hard part then is actually building up the rest of the plastics to make it fit.
Yeah.
But we should be able to do it for pretty much any vintage machine.
We need to glue the two end pieces onto the brand new HEPA filter, and to make sure that they stick properly, the first step is to sand down the mating surfaces to get a nice key for the epoxy to grab onto. After a thorough cleaning and clean up with canned air and alcohol, we're going to use a 2-part epoxy that should create a very strong airtight seal. It's a little unwieldy to slather the epoxy on, but after getting a good coating, we just need to mate the surfaces together. Once it's all lined up, we'll secure the first piece with painter's tape, then flip it over and repeat the same process for the second piece. Now we just need to let that epoxy cure for a few hours. So in the meantime, we'll get some much needed work done on the Phoenix. After sliding the entire drive out, we can now lift up and rotate the card cage out of the way, and that gives us access to the grounding lugs. DC and AC ground are inherently separated, giving the user the option to tie them together, which I want to do. And to achieve that, there is this little grounding strap that goes between the two lugs. I'll install the strap and then also connect up a big ground cable to the same lug. That cable will route out of the cabinet over to the other cabinet, and I'll bolt it to the card cage. With that taken care of, let's fire this thing up to purge for a bit. In order to do that, I need to lock the heads, but the original lock is missing, so this piece of wire will have to suffice for now. But that's really just a fallback. To actually prevent the heads from loading, we need to unplug the power to the voice coil. So, Rick, if you could flip on the PDU for me, that's gonna kick on the blowers for both the Hawks, which we definitely hear come up. Now, the main switch on the back of this one's still off, so if I flip it on, the squirrel cage on this one has kicked on. It is not quiet. All right, let's go ahead and hit start stop on here. It should start spinning. I'm still getting that fault light to flicker like that. I don't know what's causing that, but it is spinning up. The motor is indeed spinning up like normal and everything sounds all right, but the flashing fault light is still flashing. However, it does stop once the drive is up to speed and the reading light also stops flashing. After some snooping around, we finally figured out what the problem was, and it's really not even a problem. Whenever the Centurion is plugged into the Phoenix with the ribbon cables, but the Centurion is off, it causes some weird floating signal issue that tries to assert read gates or write gates while the drive is busy. The solution is to just turn the Centurion on first, then spin the drive up. At any rate, we let that purge for a few hours while the new filter epoxy set up, and it came out looking awesome. So let's get this installed in the drive so we can purge it as well. First, we need to remove the removable pack, then remove the 2 Allen bolts holding the front fascia on. After that, there are 2 more Allen bolts locking the drive down. With those removed, the whole top half of the drive lifts up like the hood of a car. This filter served us well, but it's used and around 30 years old. A new replacement is definitely something we needed to figure out, and that new replacement fits perfectly. We'll spin up the blower and check for good airflow as well as for any leaks, and it all seems to be doing really well. The 3D models for the end caps do need some slight tweaking here and there, but the filter fits and mates up exactly like the original. This is really going to work amazing, I think. So we'll set it down, check the mating surface between the filter and the inlet, and then just spin it up and let it purge for a few hours more. This is a multiple stress test because I have both Hawks on and spun up right now, and this thing pulls the most current during spin up. The Centurion is on, we're sitting at a D equals prompt. If it loads the heads successfully, that is good news. But there's only one way to find out, and that's to push the start stop button. You get the honors.
All right, here we go. We're blinking ready.
And
Spin it up.
we've started spinning. All right, so I don't know how long it's going to take before the heads load. I'm guessing 30 to 40 seconds, but we'll find out here.
Oh, I think we got it. Oh yeah, we're ready. All right, all right, all right.
All right, that's so scary.
All right, all right.
All right, all right, all right, all right. All right, let's move the cameras around, point it at something over here. All right, let's see if we can boot from it. I'll type in H1 here. It's trying to figure out how many drives there are. This is taking way longer than I feel like it should. but it hasn't started puking errors out of it. This might be one of the problems we were seeing before where the fixed platter on that thing is not really visible. Or maybe I've got some kind of DMA issue going on with the CMD card, but this should have, oh, all right. That took way too long, but max disk equals 6 is good. So we'll go ahead and enter through that, 82384, and we should get CRT0 ready here. If I do a .sta for a status, now I should have 2 CMD platters coming up here. So I should actually have 6 and 7 for removable and fixed, but the fixed platter is not being seen correctly. However, that removable platter is, oh, or not. That's a new one. If I do a .dir1, can I view console output also? What are you doing? What is going on here? Also, why did you not stop? dir2. Okay, let's try dir6 again, see what happens. That time it worked. This is so weird. Okay, good news, bad news. The good news is that the heads loaded on the Phoenix, they did not crash. The bad news is that it all went sideways shortly thereafter. I turned the cameras off, and then the Centurion started misbehaving dramatically. Couldn't get directory listings of anything, couldn't run any executable files. Just very unhealthy. So we shut the Phoenix off, did a reboot, but left the system up. Same problem with the Phoenix off. We turned the breaker off, so the Phoenix was completely eliminated from the system essentially. Still the same problem. Over the next few hours, we did a ton of pretty methodical testing. And at this point, we're pretty sure that it's either a memory problem or a CPU problem. And a bad 4116 DRAM chip seems far more likely than a bad CPU. So we're gonna sit down and test all of the 4116s. There are some built-in tests on the Centurion, but this seemed like the easiest and fastest way to find a bad chip. So it's like a full day later, and we've been essentially slamming our head against the wall with this thing. We did find 2 bad memory chips. Those have been replaced, but didn't solve our problem. We're still getting weird random errors. Sometimes it can boot in the operating system, sometimes it can't. It's still screaming a memory problem to us, and enough of it is working that I can boot into diagnostic programs on the Hawk. So one of those diagnostic programs is indeed a memory test. So if I type H1 here, I've pressed the select button, so we should get to a name equals prompt. Yeah, there we go, and I can do question mark dot question mark TMOS. That's gonna be on disk 1, and yeah, there we go, MOS Memory Diagnostic 6.6. Let's do a data test here, and it's gonna ask me for the memory board size. We think this is in kilobytes, but we're not sure. I mean, there's no documentation on this thing. So we're gonna do 128K for that. We think the chip size are 16K chips. Gonna do the exact same thing for memory board 1, and again, 16K chips. And then what it's gonna do now is it's gonna test if it can relocate its own code into a different part of memory and then execute from that part of memory. So that way it can run a memory test without overwriting itself. And there we go. It seems that it's happy with the ability to relocate. So it says, are all boards set for normal rotation? Yeah, we're just gonna go ahead and yes on that. Now it's gonna ask me for my start address. I can't do anything lower than 0100 because that's where the CPU registers live. So we'll do 00100 as our starting address. And then our ending address is gonna be the extended range. So we can go to 3EFFF. I think that's right, we'll see. Yeah, it took that, okay. Now, we've been here before and this is hilarious. I gotta show you guys this. Let's do a various pattern test. So I'll go ahead and hit option 4 here. And it says, approximate test execution time, 5 days. No, I do not wish to continue. 5 days. All right, there's no. So we'll just do a fixed bit test. In our earlier testing, the fixed bit test runs much faster, although it's not nearly as robust. This is probably going to take about 10 minutes to run, so we'll just sit back and let it go. And there we go, fixed bit test successful. That tested pretty much the entire extended memory range, but we could still have something that's marginal and wouldn't be checked, wouldn't be checked by a fixed bit test here. All right, we've been playing with it for a little while longer, and at this point we can't seem to get it to misbehave. Something is still very much so broken, but we can't troubleshoot it if it's not acting broken. So I guess we're just gonna soldier on. So I'll do a question mark dot question mark CMDTST. The file is located on disk 1. And here we go. This is a CMD disk diagnostic test. But the one that I'm interested in is the one that says F here for format. So I'm gonna go ahead and hit F. I've got physical write protects on for everything except for the fixed on the CMD. So I'm just gonna go ahead and put platter number 1 into here. We'll hit enter on that. We'll just do like 100 just to get like the base. We'll see if this actually does work. So we'll go 100 hex. The printer I think is 0. That's gonna be our CRT 0. Format pass platter 01, start track 00, end track 0100. It's not throwing an error, but it's also not doing anything. Oh, it is doing something. The lights on the front panel are moving. Format complete, space to continue. That's excellent news. All right, so let's do a space, and then we'll exit out of this. So I'm just gonna hit the load OPSYS button. We'll go H1. This is gonna boot us all the way back up into the operating system. And if just formatting that base, if that actually makes the operating system happy, it should say max disk equals 7. It does say max disk equals 7. That's what I'm talking about. Let's go. All right, now when I get into STA here, it should say that it's it's a CMD, but it's showing up as like a CPU 5 platter because the bits don't make any sense to this. So we need to do something now called an s.newDisk, s.newDSK. The disk number is gonna be 7. Disk 7 is guarded. So we wanna do a .noguard on 7. And then we're gonna run an s.newDisk again. Disk number 7. New disk name is gonna be MX Shift. I am ready, yes. This is probably gonna take a while, so we're just gonna sit here and let it run and see how it ends up. And on the second pass, it found a completely bad track. 135 was completely bad, and then that caused the bad sector table to overflow. That's not good. I don't really know how to overcome that. We'll go ahead and cancel out of this, yes. So it should get us back to the OPSYS, and I should be able to do a .STA. The drive should still be somewhat visible in there. Yeah, it says init now. So we did actually get some data down onto that fixed platter. I don't know, we're gonna keep playing with this, and hopefully the next time I see you, we'll have some good news.
Funny smell. What's that? The temperature light?
All right, so I think the last thing that I said to the camera was, hopefully next time I see you, I'll have some good news. I don't. I have bad news.
Bad news.
We had a head crash. I think what happened here is that when we ran the format, we got all the way to the inner area of the disk, and it picked up some smuts in there that we would not have hit if we were just reading the disk as normal. So when I did the removable pack in there and we were doing directory listings and whatnot on that, that was totally fine. We'd been doing that all day and never had a single problem. It was only when we ran the format that we started smelling lacquer after that.
Yeah.
It's a very noticeable smell.
And the removable pack isn't particularly full either, so it's like the data and the directory listings and everything would be all in the outer regions of the disk. So.
Yeah. But there is hope, because when I went to VCF SoCal last year, there was an amazing gentleman that showed up with a bunch of Phoenix parts, and this was one of them. This is a replacement fixed platter stack for this drive. I was hoping to never need it, although now we're in the situation where we need it. So I think the next step with this drive is to fully tear it down, get the replacement fixed platter stack in it, and hopefully spin it back up and reformat that fixed platter and get it going. I have no idea what that procedure entails. It's gonna be very difficult.
And there's going to be a lot of investigation when we do it because we don't know what the condition of the heads are anymore.
Yeah, well, yeah, we know the condition of one of them is borked.
Yeah, is it recoverable? And those we don't have replacements of. So
before we go, we still have no idea what's wrong with the weird errors that we were seeing. Those just straight went away and never came back. So we're gonna let the whole machine cool down and dig back into that as well. So we gotta fix the errors, we gotta fix the Phoenix drive, and once we get all that going, there's a little something extra that's hiding out in the frame that we wanna get going on the Centurion as well. So thank you all so much, and I hope to see you in future Centurion episodes.